All right, good afternoon, everybody, and welcome to this free webinar brought to you by the Biomass Thermal Energy Council and the Alliance for Green Heat. My name is Peter Thompson from the Biomass Thermal Energy Council. I will be your moderator today as we work through this elimination of carbon monoxide off-gassing and stored wood pellets webinar. Before we get started, I just want to go through a few housekeeping items. As you can see on the screen, there are two ways to access the audio for this webinar. You can use your telephone, landline, or cell, or you can use the mics and speakers to your computer. If you're having any issues hearing me through either of those options, I would recommend switching to the other option, and maybe the quality will be a little bit better for you as we move through the webinar. As we have the presentations going on, I would encourage anybody, if you have any questions, to use the questions panel on the side menu to type in your questions there. We will get to all of your questions at the very end of the webinar in a Q&A session with our presenters, Kelly Ramsey and Dr. Phil Hopke. And I guess that's it for the items there. The agenda of today, the welcome and introduction, which we've just done. I'll give you a brief overview of the Biomass Thermal Energy Council, and John Ackerley will be giving you an overview of the Alliance for Green Heat. And then we'll get into the nitty-gritty of our webinar today with the elimination of CO off-gassing from stored pellets, presentation by Dr. Phil Hopke, and then we'll move into an industry perspective and involvement from the Cure and Renewable Energy from Kelly Ramsey. After the conclusion of those two presentations, we'll move into a question and answer session moderated by John Ackerley and myself. All right, to get started, the Biomass Thermal Energy Council, we are a national trade association for the modern wood heating industry. We have 60+ members and associates across the US and Canada, from fuel producers, manufacturers, sellers, installers, and we engage in technical codes and standards development, as well as public advocacy and outreach and education to the general public. If you're interested in getting involved with the Biomass Thermal Energy Council and any of our membership offers or our government affairs fund that we've just launched in the past couple of weeks, you can contact myself or Executive Director Jeff Surface with any questions you may have, and we can help you get set up and hooked into the Biomass Thermal Energy Council in any way that you are interested in. And with that, I'm going to hand things off to John Ackerley, the Executive Director of the Alliance for Green Heat. John, take it away.
Okay, thanks, Peter, and thank you to Phil and Kelly for doing this, and to all of you who are on the phone. Alliance for Green Heat is a small nonprofit. We're based in Maryland. We're founded in 2009, right around the same time as BTEC, and we focus on residential biomass. And our goal is to promote cleaner and more efficient residential biomass heating. We mostly focus on stoves, wood stoves and pellet stoves, but also boilers, and to a lesser extent, institutional scale biomass heating. And we try to advocate for consumers. We're a nonprofit, so we don't represent industry per se. We work with all stakeholders with a real focus on the people who use the technology. Next slide. And our big event this year is the Wood Stove Design Challenge. This is the 4th year we've had it. It's going to be on the National Mall in November. I would invite anyone who can to attend. It has 2 categories this year. They're automated stoves and stoves that produce electricity. And we are very excited. We have 12 stoves in the competition, and they will be, some of them are very innovative, very new. There's very little like it on the market today, and part of the goal of this is to see that there's a lot more of these stoves on the market in a few years. So with that, I turn it over to Phil.
Okay. So I'm Phil Hopke. I was at Clarkson University for a long time, moved down to Rochester about a year ago, but still using my Clarkson email. So those of you who may have an interest, you may want to note down the email at the bottom of the screen there. I'm more than happy to answer questions or interact with you afterwards to talk about the process and the problem. Next slide, please. And you know, as any faculty member, I don't actually do the work. I sit in my office and write proposals and papers and reports. So postdocs, Lydia and Mohammed and Stefani, and grad student Shinru, and fellow faculty member Alan Rossner, who did a lot of the field work and lab work that we're reporting here. I certainly want to give a big thanks to Pat Curran and Curran Renewable Energy for their collaboration. They've been invaluable in this, and of course to New York State Energy Research and Development Authority for the financial support that allowed us to do it. Next slide, please. So, you know, this, as I'm sure most of you are aware, the northeastern United States is one where we still burn a lot of #2 oil for space heating and have a lot of residual wood that was actually planted for pulp and paper. And in many cases, the pulp and paper industry has dried up. So there's significant forest reserves out there available that could be harvested and allow us to have much improved economic development within the region of northern New York, northern New England, by heating with renewable wood. Next slide, please. So about 10 years ago, as fuel prices were starting to rise and there was increased interest in burning wood, NYSERDA was also interested in making sure that the wood was burned well, such that we, you know, could keep a reasonably sustainable wood supply and at the same time reduce the amount of pollution being generated by a lot of the inefficient appliances that were in use at the time. And so they started to make an effort to bring in European wood burning technology, particularly pellet burning technology. And as a result of that, a number of wood pellet boilers were installed in schools and museums across the North Country with NYSERDA support. Next slide, please. And so in August of 2012, NYSERDA was alerted by the New York State Department of Health about a paper reporting incidents in Europe of people going into large storage pellet storage bins, encountering very high concentrations of carbon monoxide and dying. Next slide, please. This is the paper, and having just put a wood pellet boiler into a middle school with the old coal bin under 3 classrooms being the storage area for 30 tons of wood pellets, NYSERDA was concerned that they might have, in fact, created a hazard that was affecting the school children and asked us to see if we could look into it. And so we developed a program to monitor bins, but let's first review some of the other literature that's out there. Next slide, please. Turns out there's actually a more extensive literature, but it didn't seem to have registered very strongly with a lot of people. So next slide, please. Particularly back in Sweden, back in the early 2000s, Urban Svedberg, published a series of papers. One of the first was on the emission of volatile organic compounds, particularly hexanal, as well as carbon monoxide from large and small-scale storage of pellets, and recognized that hexanal could be associated with the potential for occupational and domestic health hazards. Next slide, please. And so also showed that lumber drying also tended to produce hexanal and carbon monoxide, not just from wood pellets, but basically from any wood process, but it depended on the amount of surface area of wood that drove the amount of emissions that were being seen. Now, they suggested that the carbon monoxide and the hexanal were formed by the autoxidation of fatty acids in the wood, and we'll talk more about that in a bit. Next slide, please. Turns out in the mid-2000s, there were a series of ocean-going vessels that were shipping pellets, primarily from Canada to Sweden, and resulted in people going into the holes before they were well ventilated, and a series of deaths occurring in several of these, even though, again, there were actually guidance documents out there suggesting the need for substantial ventilation of the holes before going into them. Next slide, please. And so 5 fatalities within a 2-year period. And again, inadequately ventilated stairwells communicating with the cargo holds. Next slide, please. So over the last 15 years or so, there have been 14 reported deaths. And the problem is, of course, we generally store pellets in occupied structures, and so there was a potential for exposure, and NYSERDA then asked us to see if there were unsafe concentrations of carbon monoxide in use pellet bins that had been, particularly those that had been installed as part of their demonstration projects, and particularly this installation under middle school classrooms. So next slide, please. So we set up carbon monoxide monitoring in a residential basement in Messina, where they had a 10-ton bag pellet storage facility, which you'll see later in Kelly's slides. 3 locations in the Malone Middle School, Saranac Lake Elementary School, which had an outside silo, and a couple of systems we had at Clarkson, a 20 kW energy cabin and a 150 kW Hammett pellet boiler, and then at the Wild Center in Tupper Lake. Next slide, please. So here is the residential, back please. Here's the residential slide, which is showing you that in this basement, residential basement, we were, in fact, periodically, particularly when fresh pellets were put into the storage bin, seeing exceedances of the 9 ppm ASHRAE guidance for indoor carbon monoxide levels. And so next slide, please. And so you can see there are a number of values over 9, averaged on 8 hours. And as I say, this is the same guidance as this guidance is the same as the NAAQS for CO. And so although these don't really represent an acute hazard to the people living there, they do represent an unwarranted health hazard, particularly to susceptible individuals. And so it's certainly an undesirable outcome. Next slide, please. So we also then looked at a couple of occupational settings, but particularly a large, these storage bins are occupational settings. The silo at the middle school or at the elementary school, the pellet bin under the classrooms in the middle school, and the storage facility at the Wild Center. And I'm not going to show you the details there, but we, in several cases, wind up with concentrations exceeding 50 ppm, which is the OSHA regulatory standard. So therefore, these then become confined spaces, and you have a little school district like Saranac Lake having to set up a confined space protocol, do training, do permitting, and all of the other hassles that go along with a confined space. And that's, again, certainly going to inhibit people from utilizing wood pellets for heating when they have this extra hassle and expense to set up these processes. Next slide, please. So we've published all of this material a couple of years ago. Again, anybody who wants a copy of these papers, just send me an email and I'd be happy to email you copies of these back. Next slide, please. Now, then a couple of years ago, the question came up, well, all these previous studies have been of bulk pellets, but a large fraction of the people who are using pellets are buying them in 40-pound bags, typically a few tons at a time, and storing them in the basement or the garage. So is that a problem? Because again, the bags aren't sealed, because in order to be able to stack them, you're going to have them perforated so the air can come out of them as one bag is stacked on another. Again, you'll see pictures of this in Kelly's slides later. Next slide, please. So do bag pellets off-gas sufficient carbon monoxide and carbonyls, hexanal, formaldehyde, other things to be a problem? So we went to a pellet storage warehouse. Next slide, please. And you'll see that we, again, published this material at the end of last year and the beginning of this year for CO and for the aldehydes. Next slide. Keep going. I don't know why I didn't think I had. Okay, so here is the carbon monoxide data. And again, the dashed line, the dashed red line is the 50 ppm OSHA regulatory standard for 8-hour exposures. And you can see that these are being exceeded at various times over this time interval. And so we do have then an issue with regard to the exposure of people. These are measured at several locations in the warehouse at different heights above the floor. And so you can see that we are getting then a situation where this technically violates OSHA regulations or would require it to be defined as a confined space. Next slide, please. Again, we've also looked at the carbonyls. We're presenting them in a little different way in several different time frames. So the black is the first set of measurements, the middle gray is the next, and then finally the third set. So you can see over time, the carbonyls are increasing. The top of the bar is the average concentration. The error bar is the standard deviation. And you can see that we, again, are getting some values that are exceeding the OSHA action level for formaldehyde. There are no problems with any of the others, although there is potentially some sensory irritation coming from the hexanal if people were to be spending extended times in there. So there's clearly a potential occupational problem also that you might have at your mill, depending on how well ventilated your pellet storage area is. Next slide, please. So we also then did a series of laboratory studies, next slide, in which we took a 20-gallon drum, poured in pellets to fill it about halfway, and then measured the carbon monoxide in there as a function of time. Next slide, please. And you can see that the top curves there are for softwood and for blended pellets, which were mostly softwood, and then the lower set of curves are for hardwood. And you can see that after 15 or so days, sealed up in there, we're getting of the order of 800 to 1,000 ppm of carbon monoxide with softwoods and something of the order of 400 ppm of carbon monoxide with the hardwoods. So clearly we're getting significant amounts of carbon monoxide off-gassing from these pellets. Next slide, please. So we also then did bagged pellets, so we could take 2 bags of pellets, put them in a 55-gallon drum with, again, a carbon monoxide monitor. And next slide. And again, you can see that Depending on the temperature and the time, we can also still get up to of the order of 1,000 ppm of CO. So the bag itself is not precluding effective off-gassing of the carbon monoxide. Next slide, please. So this is very puzzling, why in the world, there had been this hypothesis that it was the fatty acids, but that seems hard. So next slide. So as I say, several groups, including Svedberg and these people at the University of British Columbia, suggested it was autooxidation of the fatty acids. That's what causes your food to go bad. If you think about things like olive oil hardening or linseed oil hardening, that's all from autooxidation. But we had been developing methods for looking at fatty acids as part of another project we had ongoing in the lab. So next slide, please. And the problem is that there isn't enough fatty acids there to explain more than 3 to 8% of the mass of the carbon monoxide. So it cannot be what's responsible for the bulk of the carbon monoxide. It certainly is responsible for the hexanal. So, wood is cellulose, hemicellulose, and lignins that we typically determine with thermogravimetric analysis. Next slide, please. So, and if you can click through this, there should be several arrows. Next slide. Yep. So there is the hemicellulose peak. Next is the cellulose peak. And next is the lignin peak. So we had a TGA upstairs, so I sent Lydia up to do some TGA on our pellets. Next slide. And you can see we're seeing similar kinds of things. We don't have quite as good a resolution. Everybody publishes the best figures they ever had. So next slide. So if we let it sit for 6 weeks, you can see that there is a difference in shape. And if we superimpose those two, next slide, you can see that it's the hemicellulose that's going away. That the cellulose is basically the same, the lignin is basically the same. So aging caused the hemicellulose to get oxidized. But that's very strange. Next slide, please. Because hemicellulose is not going to react with oxygen at room temperature. There has to be a stronger oxidizer that would attack it. It's too stable a molecule. Next slide, please. So we could suggest that it could be reacting with something like hydroxyl radical, which is the strong oxidizer in the ambient atmosphere. But the question is, how do we get a strong oxidizer like that in a barrel, closed up, no sunlight, no heating, and so on? So, however, the hexanal says that we are getting autooxidation. And it turns out if we go to the literature and look at the mechanism for autooxidation, part of what happens there in a very complex chemistry, which I didn't put the slide up because it would make everybody pass out, would produce hydroxyl radicals. So we have a mechanism for producing hydroxyl radicals. So what we can think about this is a two-stage process. The autooxidation of the fatty acid produces the hydroxyl. The hydroxyl can then undergo a chain reaction with the hemicellulose to produce the carbon monoxide we're seeing. Next slide, please. Now, we can check that because we can put in something which would react faster with the hydroxyl and then hopefully then make the carbon monoxide go down or go away. Next slide, please. And so if we put in short chain alcohol, a butanol, you can see that we reduce the carbon monoxide to roughly a third of what it would be without it. Next slide, please. So we can then think about this as being this two-stage process, and that gives us then the opportunity to fix it. Because if we then react the fatty acids, which have a double bond in them, with ozone, we will break them down before they get formed into a pellet or on the surface of the pellet before they go off to storage and potentially eliminate the problem. Next slide, please. So if we expose pellets overnight to ozone, you can see that we've substantially reduced the carbon monoxide, the red one. And again, if we put in the hydroxyl radical scavenger, it goes down even further. But we haven't fully eliminated it because part of the interior of the pellets then didn't get exposed to the ozone, and those fatty acids didn't get decomposed. Next slide, please. So what we can do is to have more surface area to passivate. Next slide. And so we can run up and get the ground wood fiber before it goes into the press and expose it to high ozone. Next. And now you see that the treated material produces no carbon monoxide. So that gives us then the real promise of a process that will eliminate the hexanal emissions and the carbon monoxide emissions. Next slide, please. So what we need to do then is to be able to react the fiber with ozone as it moves through the pellet mill process. Next slide. And so in order to do that, we have to know how fast this reaction is, how well we have to mix things, all that kind of good stuff. So we acquired an auger and added ozone so that we could do some laboratory experiments to try and see how much ozone, how much time was needed. Next slide. So there's our laboratory auger. Next slide, please. And there it is in the laboratory. So the fiber is down at the bottom, it augers up, and the material then dumps into the black can. We have an ozone generator and an ozone monitor under the table on which the fiber is going into it. Next slide, please. And you can see that as we increase the ozone concentration from no ozone for the red at the top down to 6,000 ppm of ozone at the bottom, we can make the carbon monoxide go away. And if we combine these, we've actually done two different runs, one where we had 7 minutes of time of exposure and another with 3.5. Next slide, please. These actually, all these points fall on a nice line when we think about it in terms of the product of the concentration times the time, that's an exposure. And we get this wonderful straight line with two different experiments, two different times. And so we think we understand how much ozone time exposure is needed in order to make this happen. Next slide, please. Now, we don't want the ozone to break down the basic properties of the fiber so that it will no longer make a good pellet. So we took our ozone exposed fiber, did another thermogravimetric analysis on it. You can see now we still have the hemicellulose, the cellulose, and the lignin. Particularly the lignin's important because that's what binds the pellet when you hot press it. Next slide, please. So then we needed to see whether we could make this work in a real mill. And so it should be easy to implement, relatively low in cost. And we recognize that the pellet market is currently depressed, and so we need to be efficient and cost effective if we're going to have something that's going to actually make sense for anybody to use. Next slide, please. So we went up to current renewable energy. We had our ozone generators. and a oxygen concentrator, because what you'd really like to do is use relatively pure oxygen to go into the ozone generator. Fed that into the mill. Next slide, please. And you can see that then we had no exposure. So we took some samples before we started putting ozone in. Took 3 different samples. You can't really tell them apart because they're overlaying one another down at 0. So we have successfully made no CO pellets at roughly full scale. We had 3 of the 5 mills going at the time in a normal production run. So we're quite confident that we have a process now that is able to eliminate the problem of carbon monoxide, eliminate the problem of the carbonyls, and it will also, for the softwood pellets, eliminate the terpene smell. When we started up the ozone in the mill, you could smell very quickly the reduction in the terpene smell, the alpha-pinene smell, as the ozone also reacted with the terpenes to break them up and reduce them as an odorant. So next slide. So you're going to hear shortly that Curran is currently working on installing this, and NYSERDA is likely to want to help all of the New York State mills to utilize the process. And so we believe we can eliminate the potential for occupational and environmental exposures from stored wood pellets. Next slide. And that's, thank you very much.
All right, thank you very much, Dr. Hopke. Next, we're going to move into Kieran's presentation with Kelly Ramsey. I believe she's the Marketing Director of Kieran Renewable Energy. Kelly, go ahead and take it away.
All right, hello everybody. Thank you for joining in today. If you could go to the next slide, and then the following as well. Thank you. I just want to say thank you to everybody at Clarkson, which is located in Potsdam, New York, just a couple towns over, as well as Richard from Queen Air in Ogdensburg, New York, and NYSERDA, which approached us a few years ago to see if we would be interested in essentially being the testing facility for this new technology. It had been brought to our attention through NYSERDA that there could possibly be a concern of the storage of wood pellets that could be a safety concern for the consumers. A couple years ago, they had asked us as manufacturers, and then also to some of our stove retailers, to start handing out handouts or pamphlets that essentially listed a required outdoor storage because of this issue. So from that we realized this was probably going to be something that would be brought more into focus, and it would be a concern that we'd want to address as well. Next slide. And as many of you know that are probably on the line, as a pellet manufacturer, there's so many challenges today. Incredibly unpredictable weather patterns and oil prices and fluctuating exchange rates, which can really make all of our jobs challenging. We're really always, striving to move forward and battle these market conditions, and having one more possible hurdle could really make this industry more challenging. And with the concern of the carbon off-gassing and some of the reporting that we had read, that people were becoming sick or even had died from it, so it definitely was a concern for us. And if there is any technology or method to make the consumer safe and more confident in using and storing wood pellets, we felt like it was important to get involved and see if we could help this technology be developed and essentially be the test subject or guinea pig for Clarkson. Next slide. So as Phil had said earlier, they did a study on some bulk loose wood pellets that were in the basement of my parents' home, the 9-ton fabric bin with a wood pellet boiler set up. And then they also tested the the warehouse where we stored at any time, you know, hundreds to even a couple thousand ton, depending on the season, of bagged wood pellets. And then also the findings, like Phil had said, the lab scale models were successful in introducing the ozone and eliminating the off-gassing of CO, and they had a very successful live test here this past fall that proved that they were able to eliminate the CO. Right now we have a full-scale commercial system in place, and we are testing it on a daily basis, just trying to make sure that we've got everything running. So we're currently in the monitoring phase and reporting to Phil and then also Richard and Mohammed from Clarkson to keep everybody up to date on what we're finding. Next slide. And this is just a picture to kind of give you a better idea of the fabric bin storage in the basement there at my parents'. Next slide. And just a picture of bagged wood pellets in our warehouse. Go ahead to the next slide. And now from here, I've got Richard on the left. He's from Queen Air. He develops the ozone machines. Mohammed from Clarkson, and Phil, forgive me, I may have, I'm not sure if that was Stefania or Lydia in that picture, so if I put the wrong person's name, I do apologize. And then Phil Hopke here on the right side.
Yeah, that's Stefania.
Okay. Next slide. So the process of putting or removing the carbon monoxide, you know, that's there to benefit our employees here. So there isn't the work hazard of being exposed to the carbon, and then also to the homeowner. But in doing so, we have to inject the ozone into this process. So for us, we wanted to make sure, although we're removing one harmful, you know, gas, that we're also making sure that our employees aren't overexposed to any ozone. So each time Clarkson has been here, they've made sure that the injection is going, you know, is being absorbed into the wood. That's our hope, is to make sure that it's fully absorbed into the wood fiber and that there is no excess in the air that would be then exposed to our workforce. Next slide. So we have a couple different monitors that we keep on hand. The mill operators have this AeroQuil 500. I've got a picture of it here with also a secondary sensor, which we purchased as well. They keep that on hand right out there in the mill. It's mobile, they can walk around with it, but they also keep it right there with them in the operating room at all times. And then this smaller EZ1X is something I keep in my office just for my own sense of comfort, to make sure that the ozone exposures aren't of any concern to any of us here in the office. And so far I haven't seen anything that's been of concern, so we're very happy about that. And these are about, I think the AeroQuil was around 14 or 1500, and then the EZ1X was around 400. Next slide. Now what we've been doing when we do these tests is we're filling some 10-gallon steel drums about halfway and putting carbon monitors, CO monitors, these USB monitors within it. Right now we're kind of testing on average every 10 days to see that the carbon monoxide is dropping. And then there's also a temperature monitor that we'll put in one. But right now we're doing 6 CO monitors each time we do the test. Next slide. So the ozone is injected into the wood before it is pelletized, as Phil was explaining in more detail. And then our system here at the mill is designed to shut off this technology automatically if the pellet mill happened to shut down. That way there isn't just free, you know, exposure of ozone in the air. And the samples of pellets are taken and stored in the steel drums, like I had mentioned before. It's very simple to do. It's not labor intensive. It can really be done in just a handful of minutes. And then I export the data to the team over at Clarkson, and also to Phil for them to kind of give us some feedback of how things are going. And one thing Phil had mentioned earlier, was the terpenes. It is like night and day I'll admit I'm pretty immune to the smell of wood fiber now, being here for 9 years. However, when we make soft wood pellets, I find it's incredibly strong smelling, but with the ozone, it just completely depletes that really heavy, dense smell in the air, the terpenes. So you really do notice a significant difference. Next slide. And here's a picture of Phil and Richard with the air concentrator, and then down below is Mohammed and Phil with an ozone machine. From speaking with Richard, one thing that he's trying to do right now is make this two-box system possibly into a singular unit, so it's even smaller, one less thing that you'd have to install, so it really wouldn't take up much space at all. Next slide. So the investment overall with the ozone machine, the USB monitors and the ozone monitors as well is relatively low. It's less than 10,000. And like I mentioned before, the testing is very simple, and the system itself takes up minimal space, and it was installed within minutes. Next slide. And really, for us, as a manufacturer, our hope is that the technology can be easily adopted by any pellet manufacturer. It's not just to us; it's to absolutely anybody who would be interested in, to help the industry as a whole increase our market share. The outcome from the technology battles any fear regarding the safety of wood pellet storage that could affect the market, and we hope that the system will eliminate any occupational hazard also to our employees that work in the warehouse that are exposed to higher concentrations, as well to any homeowner that may doubt wood pellet safety. Next slide. And I just wanted to thank everybody that's been involved, and again, if you have any questions, let me know. And that's it.
All right. Thank you, Kelly. We really appreciate you taking the time to join us today and let us know about Curin's role in this elimination of harmful carbon monoxide. Now we're going to move into the question and answer session moderated by myself and John Ackerley. John, are you still on mute, or are you ready to ask some questions?
Yep, ready to go.
All righty. Why don't you get started for us? And if you have any questions throughout this session, just continue to type in your questions, and we will get to them as soon as we get through all the other ones that have been queued up for us.
Okay, we have a half dozen good questions so far. I have a couple myself that I'll get to later if they're not more being asked. And this first one is really more for you, Peter, but just everyone always wants to know if this presentation will be available later, and yes, BTEC makes them available. We'll send them out to everyone who's registered and make them available publicly in a few days after the webinar. Is that right, Peter?
Yeah, that's right. In a couple of days, probably by Wednesday or Thursday, we'll have this up on the BTEC website. Shortly after that, we'll send out a follow-up email to everybody who joined us today and registered for the webinar with the links to the presentation as well as the recording to this webinar. So you can enjoy all the fun again on your own time.
Okay, great. Well, several people have asked the question. I guess this is Phil or Kelly. A concern about ozone as an air pollution problem, both in the plant and I guess potentially even outside. I don't know how much ozone is there, but what happens to that ozone after it passes through the pellets? And how are you sure that it's not a danger in and of itself?
That may be a better question for Phil. He may understand that more thoroughly than I will.
Yep. Yeah, I expected that's my catch here. Yeah, first of all, what we're trying to do is to insert the right amount of ozone so that most of it is going to be reacted with the fatty acids and terpenes that are being that are in the wood, so that the amount of residual ozone is relatively small. And so, there's always ozone in the atmosphere, and the atmosphere has a lot of volume. So the 8 to 10 grams an hour that we're making for this 100,000 pounds of pellets a year, 100,000 tons of pellets a year, is pretty small. So it's going out with the ventilation air and is rapidly diluted, so that in the vicinity you would not notice any increased ozone concentration. And if anything, it's going to actually reduce the ozone in the downwind, because we're no longer putting the terpenes and some of the other reactive organic compounds out in the air that would actually enhance the atmospheric ozone in the vicinity. So, we want to make sure that we look at each plant and design where we put it in so that it's well contained. First of all, because we want it to contact the fiber, not escape into the plant. And if we do that right, then there's very little residual left to either escape into the plant, and the measurements we've made so far are pretty low, or be vented out of the plant, out of the building into the ambient atmosphere.
Okay. Thank you. Here's another question. Would you get similar results to hardwoods if you were working with agricultural residues and grasses? I guess along those lines with wood chips, would you expect that you'd have these same issues with wood chips?
Yeah, we've done wood chips. It basically is a surface to volume issue. The surface to volume for chips is lower than it is for pellets. And the amount of carbon monoxide scaled about as the surface area per unit mass of wood. Agricultural things, it would depend on what else is there. I don't have as good a feeling for what would be in things like grass pellets that would be potentially auto-oxidizable. I mean, these moderate chain fatty acids are pretty susceptible to auto-oxidation. Whether there's similar kinds of things in plant residues, I'm not sure. We would need to do some testing, but that'd be easy to do.
Okay. This is from Robert Linkletter. How many pellet machines can one ozone machine handle?
Well, again, in this case, for this mill, it's set up so that you have one process stream of fiber coming in from the drawing milling operation that then feeds 5 presses. And, so that by putting it into the main input auger and then potentially doing a little bit more feeding into the individual day hoppers for each press, the one ozone generator suffices for the whole plant. Now, if you had, totally separate systems, depending on where they are and how far you'd have to transport the ozone and other sorts of things, it might be easier to do 2 smaller units than 1 big unit. I mean, pellet mills are not cookie cuttered, so there may need to be a little bit of design considerations for each separate mill.
Okay, and this is from Guillermo Metz. What is the cost of the ozone system for, I guess, the whole mill?
Well, the ozone generator was about $5,000. The ozone monitor was about $1,400. Each of the CO monitors is about $140 each, and the 10-gallon drums are like 50 or 60 bucks a piece. So that's really the expense, and the tubing is trivial.
Okay. And a question from Rob Rizzo. How will this groundbreaking research be brought to the consumer? Have discussions been started with PFI to recognize CO-free pellets from typical pellets?
No, we haven't done any of that yet. We wanted to get through these tests at Curran to make sure that we had it on a routine operating basis. And then, as I indicated, NYSERDA has indicated an interest in trying to replicate this at other New York State mills. And at that point, somewhere down the line fairly soon, we would love to have the consumer educated to this potential problem. And again, we don't want to cause disruption in the pellet business. What we'd like to be in a position to do is roll this out after the solution's already in place, and people can be assured that when we have timely recognition of a potential problem and eliminated that potential.
Okay. Here's I'm going to merge a couple questions. Glenn Robinson, who runs a pellet plant in Pennsylvania, they're surprised that the studies you've done are more based on looking at larger systems, and there's only one home involved, and that was a 10-ton system. And is the policy getting ahead of the studies if there haven't been a lot of studies done on homes with 2 or 3 tons? And Glenn is saying that they've done studies looking at 1, 4, 6-ton bins, including getting pellets wet, and they've never been able to get any significant CO readings. So what's the basis for the policy towards residential?
NYSERDA's initial efforts were all in commercial scale units, so schools and museums. And so that's why we focused, they asked us to focus on the bins that they put in place just to make sure that, the state of New York was not creating a hazard. And so, and then, again, as part of this, we did confined space training, help them set up whatever they needed to do to comply. So yes, the big thing is that most pellets are stored long enough that probably not a lot of issues in homes with smaller bins, but it was of sufficient concern that Renewable Heat New York required outside the structure pellet storage. And so if we all have no CO pellets, that can go away and eliminate that constraint. And my understanding that at least some of the other states were looking at what New York had done and potentially would replicate it. So again, if we can head that off at the pass, why not? And given the relatively limited costs of doing this, it seemed something worth doing.
Okay, thanks. And another question from Peter McVie. Just as a follow-on to that, is there a plan to reach out regionally, not just New York, to pellet manufacturers to promote them having similar solutions?
Well, again, we're pointy-headed academics, so we've partnered with this one ozone generator manufacturer, and so I'm not sure how this gets turned into a business model, but you know, I would, as I say, it's as Kelly pointed out, it's relatively easy to do once we see the layout of the mill. So you know, I think this is something that could be implemented pretty straightforwardly.
Okay, thanks. And a question from Guillermo Metz in New York. Asking about the results of the off-gassing when ozone is added. Is it just O2 and CO2, and is there any concern about buildup of oxygen to the point where it's a combustion concern?
No, that doesn't give off oxygen. It, well, I mean, it gives off oxygen, but again, we're looking at very small concentrations. I mean, you're putting 10 grams of ozone an hour into, I forget, thousands of pounds of wood. So the amount of oxygen we're adding is trivial. So no, there's no issues there.
Okay, thanks. And from Peter Julovich, is there a safety emission concern for wood dust piles from sawmill operations in pallet manufacturing?
Well, again, the question is what's your ventilation? I mean, certainly those will be off-gassing these materials. But, you know, sawmills tend to be fairly open buildings with a fairly high ventilation rate. And so it's hard to see how easily, I mean, you could certainly put ozone into your sawdust collection system and eliminate the issue that way.
Okay. Peter, hey, jump in if there's some questions you want to ask her, else I'll just keep going. Question, another one from Peter McVie. In addition to so you may have answered this, or this also may be a good one for you, Kelly. In addition to the upfront ozone equipment cost, what is the operating cost for managing and handling the equipment over time?
I mean, we haven't been doing it long enough where I'd see where there'd be any additional costs, other than possibly having to just calibrate the sensors once a year. You know, you can send that to the company and they'll calibrate it for you. We bought an additional sensor with the AirQuil, just so we'd have one on hand when we were sending that out. But other than that, just replacement batteries for the USB CO monitors, and that's all I'm familiar with that I could see as being any additional operating costs, unless Phil's aware of something that could arise long term.
I'm sure there must be some maintenance cost on the ozone generator, but in talking with Richard, he saw that as being something between $500 and $1,000 a year. Mm.
Okay, thanks. Now a question from Paul Miller. Does ozone treatment significantly change physical properties of the fiber, of the pellets? I guess, is there any chance that the BTU value could be lowered?
No, we checked that, and it doesn't. I mean, again, you could see in that thermogravimetric analysis of the 6,000 ppm exposed material that you still have the hemicellulose, the cellulose, and the lignin, and the calorific content was the same, essentially the same as the untreated. The amount of fatty acids in there, as I say, is of the order of 3 to 8%. So that, and you know, some of that residue is going to stay there. That the less volatile parts will stay in the wood. So you're not losing any calorific content. And at least as far as we can see, the durability of the pellets and that sort of thing didn't seem to be any different. Kelly, have you noticed any difference?
No, nothing has seemed to change on our end.
Okay, great. I think you've addressed this a little bit, Phil, but this is from Peter McPhee. How long would it take for other pellet plants to implement these changes to their manufacturing process?
Depends on how fast Richard can crank out ozone generators or other people. I mean, there are a number of companies that make ozone generators and ozone concentrators. So I would think that it could be done over a matter of certainly in less than a year, and probably in 6 months if everybody wanted to really gear up fast.
Okay. From Glenn Robinson, how many tons can the ozone machine handle at one point in time? I mean, how large of a auger?
Well, again, we would size the ozone. We would size the ozone generator to the flow of fiber, and so again, you might need to buy a bigger or smaller. And again, the $5,000 one was one that would cover this 100,000 ton a year, and you might have to scale it up by, say, as much as 50% in cost to go up to 3 or 4 times the ozone generation.
Actually, the question is more, how much fiber can it treat in an hour?
As much as you make if we put the right amount of ozone in. So, I mean, what's your flow, Kelly?
Each mill or each press I think is around like 13 to 14 ton per hour. I mean, that's depending on what species.
Okay. And a question from Robert Linkletter. Do we lose our green label we enjoy now if we have to explain to our consumers that the ozone we inject will not hurt them or ultimately the environment?
I would hope not. I mean, I think if we explain it properly, there's certainly no residual ozone with the pellets. I mean, it's a gas. It's gone by the time the stuff goes into the bag. So, or into the bulk storage container. So I think with some proper educational material, we can make it clear that we're making a greener pellet because it's not doing anything that's going to harm anybody.
All right. Yeah, I have a question of my own. This is more for Phil. But does any European country that you know of require pellets to be stored outside or require ventilation in residential pellet bins?
I don't honestly know. A lot of Europe has these large district heating systems. That's the 2 units in which there were the problems. And so that was the mode was to develop, the central heating system separate from the residences anyway. So I'm not aware. I haven't really looked into the regulatory structure. There are certainly guidance for ships and how they're supposed to be ventilated before anybody goes below deck when they dock. But sailors apparently didn't always pay attention.
And has there been any interest in Europe in your work so far? You've gotten any?
Yeah, I've had an inquiry from. We've been discussing it with Bioenergy 2020, and they're potentially going to bring me over to go talk to people.
I was also I know the PFI conference is coming. That'd be a good place to talk to folks. Where and hopefully a lot of the next VTech Heating Northeast is another great venue.
Sure. Well, again, the key was to have a clear, full-scale demonstration so that we could really say we can make it work at a real process level.
Okay, thanks. The questions have tapered off. Peter, anything else?
No, I think we're all good. The questions have stopped flowing in, so I guess we're going to end it right about here. I want to thank everybody that was able to join us today for this presentation. I also want to thank the Alliance for Green Heat for partnering with the Biomass Thermal Energy Council to host this webinar, and really a fascinating topic. And I want to thank our speakers, Dr. Philip Hopke and Kelly Kieran Ramsey of Kieran Renewable Pellet, for joining us today and sharing their insights with everybody. Again, if anybody has any questions after this webinar ends in the next minute, you can contact myself or John or the two presenters. All their contact information are on the slides, which will be distributed with the webinar recording probably on Wednesday or Thursday. In the meantime, I want to, again, thank everybody for joining us, and have a good afternoon.
Thank you. You as well.
Thanks for hosting.